Now we will see some of the points in frequency of AC using sonometer. How this experiment is done and some of the main mistakes that you commit. One is you don't pass the wire through this wheel or the pulley. That is another problem because if you pass this wheel somewhere else, there will be friction and there will be loss of tension. So you should pass it through this wheel. That is one mistake that you do. And so this is the correct path. This is correct one. And you have to pass it through the wheel like this. Yeah. Or else sometimes what happens is you will pass the string to the wheel, but this will be hanging through the table. So it will be touching the table. That is wrong. If it touches the table, again, the weight will be lost, tension will be lost. That is wrong. It should be freely hanging. And another thing is the weights that is taken. See, here there are two 500-gram weights. So this is totally 1 kg. It is not 500 gram. This hanger also has to be taken as 500 gram along with this bottom 500 grams. So this plus this hanger, totally it makes 500. This one 500. So total it is 1 kg. You start your trials from 1 kg, not from 500 gram. Okay. And then while measuring the balancing length, that is another mistake. You don't measure the length from here to here. Actually, you have to measure it from here to here. The places where wires cross. Don't use this scale because these ends may be somewhat like this. They may be crossed like this. So if you measure the distance from here to here, it will be wrong. So if it is crossed, then this distance will be wrong. Actually, you have to measure the distance of the wire. So you can see the wire here somewhere. Distance of the wire which lies between these two bridges. From here to here, you have to measure the distance. Don't measure the distance at the ends here. So measure the L here, from here to here. So that is another important thing you have to remember. Now, how the experiment is done. So what you do here is you hang some 1 kg weight and then you make this string to vibrate using this electromagnet. Then when this vibrates with maximum amplitude, you measure the distance. So for different masses and different weights, you carry on the experiment. So G, you can take 9.8 or 10 also. That's left to you. Okay. If you take 9.8, of course, you have to choose x-axis scale as 1 unit as 4.9 Newton. That becomes easier. Okay, mass per unit length of the wire will be given. It may not be the exact value, maybe different values also sometimes. It need not be 21.4 into 10 to the minus 4 only. It may be something else also. Okay. Then if it is the same value, okay, you can use it, but it will be given in the question. This, you can use any value, 10 or 9.8. Now, so for 1 kg, you measure that, of course, balancing length, say 37 into 10 to the minus 2 meters. Tension is mg into 9.8, that gives 9.8, into 9.8, that gives 14.7, into 9.8, that gives 19.6. So you will get all mg values. Tension is mg value. Now, you have to plot a graph. Of course, once you get length, then you have to square it. When you square it, 37 into 10 to the minus 2. 37 into 10 to the minus 2 will not be 0.1369. Here you may have a 10 to the power that is missing. So how much it is? 37 into 37 into 10 to the minus 4 it will be. So if you go for 37 into 37, 37 into 37, that answer will be 1369. 1369, so this will be 1369 into 10 to the power minus 4. Okay. Totally its value is 0.1369. Or you can write it as 13, so you can write it like this way also. 13.69 into 10 to the power minus 2 also. It is left to you. Suppose you take 29.3 into 9.8 is 29.4. Okay. Then the balancing length is 63.8. So if it is done at 63.8 into 63.8, 63.8 into 63.8. So that will be 4070.44. If it is 4070.44 into, so 4070 into 10 to the minus 4. Then if you bring the 10 to the power minus 4, that decimal point, it will be 0.4070. You can write it as 0.4070 or 40.7 into 10 to the power minus 2. It is left to you. Okay, once you write all these values, you have to draw a graph. a graph with the x-axis we are plotted for tension, y-axis L square, meter square. So here they have used all the point values, or you can take it as say this is 0.05 here they have taken, or you can take it as 5 into 10 to the power minus 2, 1 into 10 to the power minus 2, sorry, 0.1 into, sorry, 10 into 10 to the power minus 2, 15 into 10 to the power minus 2, 20 into 10 to the power minus 2. Anyway, you can write it because you might have written it like this. Anyway is possible. So you can take it as 0.1, 0.15. You can take this as 0.4 or 40 into 10 to the power minus 2. But if you are taking like this, then you have to write in the unit, you have to write not 0.05 meter square, you have to write 5 into 10 to the power minus 2 meter square for one division. That is you have to include this 10 to the power minus 2 also. Okay, then plot the points, join them, then draw the a triangle here and find out what is y and by x. So slope is delta y by delta x. That is A is written here, B is here, C is here. AB into y scale, y-axis into y scale, the length in the y-axis into y scale, BC into x scale. Okay, what is this slope here? Slope is equal to AB. AB is 1 unit, 2 unit, 3 unit, 4 unit, 4.2 or 4.3, something like that. 4.3 into y scale, that is 0.05 or 5 into 10 to the power minus 2, because as you move here, every 1 unit gap is 5 into 10 to the power minus 2 difference. Here 40, here 45, 50, 55 like that. So 5 into 10 to the power minus 2, or you can write 0.05 y-axis. X-axis unit is, so here I have taken 4.9 itself as 1 unit distance. If you have multiplied it by 10, then you can take it as 10, 15, 20, 25 like this. So you can take it as 5 newtons, 1 unit. That's you can choose anyway. BC, 1 unit, 2 unit, 3 units. 3 into 4.9 into 10, only that much, no 10 to the power. So calculate this, then yeah, once you calculate this, you will get we'll get the slope. So it is written here 0.05 into 4.2, 4.9 into 3. So that comes to 0.0142 Newton per meter. Okay, because it is Newton per meter. Newton, tension in Newton. This is meter square, it should be, yes, because length is written as L square. So this is Newton per meter square. A correction. Yes, meter to the power minus 2. So here Newton per meter square, or Newton meter to the power minus 2. Then how do you calculate frequency of AC? 1 by 4 into root of m into slope. So better you calculate this value by taking all these values or whatever the value you have in your calculator, because most of the students struggle in calculating this. So f is equal to 1 by 4 into root of, so slope we have got it as 0.0142, that is slope. Yes, a mass per unit length, sorry, first mass per unit length, 21.4 into 10 to the power minus 4 into, suppose if I had written this as 1.42 into 10 to the power minus 2, say. 1.42 into 10 to the power minus 2. How do you do this? I have written this as 1.42 into 10 to the power minus 2. Multiply these two numbers, then you will get 10 to the power minus 4 and 10 to the power minus 2. That will remain with 10 to the power minus 6. So 1 by f is equal to 1 by 4 into root of 10 to the power minus 6. 21.4 into 1.42. 1.42. That is equal to 30.388. 30.388. 30.388. That is equal to 1 by 4. And this will be written as 10 to the power minus 3 because square root of 10 to the power minus 6 is 10 to the power minus 6 to the power half. So 10 to the power minus 3. What is the square root of 30.388? 30.388 square root. Yes, 5.512. 5.512. 5.512. Now what I can do is, I can bring this 10 to the power minus 3 to the numerator. So what will be the frequency? That becomes 1000. So 1000, because 10 to the power plus 3 it will be when I bring it to the numerator, divided by this 4 into 5.512. That is equal to, so I can do it easily like this, 1000 divided by 4, so that will be 250, divided by 5.512. 5.512, that is equal to 45 point something, we have got 45.355, 3567, 36 hertz. Actually, your answer should be very close to 50 hertz because frequency of AC is 50 hertz. So in this way you have to do. You practice this because you must know how to bring this 10 to the power minus 6 outside the square root to the numerator, divide it, because finally you shouldn't lose marks simply for calculations. Okay, thank you.